Here's our Unit 8 Day 2 video. What we're going to be talking about today is working with factorials. So first thing, we talked about factorials a little bit way back in Unit 1 when we were working with binomial probability and binomial coefficients. So we'll go back over what a factorial actually means. So definition, if n is a positive integer, then n, the exclamation point, which is n factorial, the way we say that, it's a product, it's a multiplying of all positive integers from n down through 1. So the way we'd write that is n factorial is n times 1 less than n times 2 less than n until we got down to times 2 times 1. So one important note here, by definition, 0 factorial is 1. So we say 0 factorial is always 1. So just a couple examples. 1 factorial, that would just be 1. 1 is the only positive integer there, so there's nothing else to multiply. 2 factorial would be 2 times 1, which would be 2. 3 factorial, 3 times 2 times 1, which would be 6. 4 factorial would be 4 times 3 times 2 times 1, which would be 24, and so on. So one important thing about using the factorial is grouping. So factorial only applies to the term it's attached to. So these two things look similar, 2 times 3 factorial or 2 times 3 factorial. So the notation is what makes this difference. This is saying 2 times 3 factorial. So 3 times 2 times 1. Right, so that would be 3 factorial is 6. That would be 2 times 6, and that's 12. Versus on the right, it's saying 2 times 3 factorial. So that's 6 factorial, which would be much different. It would be 6 times 5 times 4 times 3 times 2 times 1. Should make 720. So it's very different. So factorial only applies to the term it's attached to. If we want to say a sum or product or anything in the factorial of that, we have to use grouping signs around it in the factorial at the end. So most time working with factorials, they're going to be in fractions, and evaluating these numbers is difficult to do on a calculator because they're so large. Sometimes you'll actually overload your calculator by using some of these factorials. So you want to learn to understand the concept behind them and cancellation and how we can simplify these in fractions. So the first one we'll write out all the way, and then we'll kind of use a shortcut what we see happening with the cancellation to do the second one a little bit quicker. So this first fraction is 10 factorial over 2 factorial times 8 factorial. So this first one we're going to write all the way out. So 10 factorial will be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 2 factorial is just 2 times 1. And then 8 factorial will be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So we see here is a lot of repetition. So right here I have 8 factorial. Right here also have 8 factorial. Right, so all of these terms will cancel out. And I'd be left with 10 times 9 over 2 times 1. And even then I can keep simplifying. 10 over 2 is 5 over 1. So this turns into just 5 times 9, 45. So it's the same here with the second one. You might recognize this is the formula from our binomial coefficient, which we'll be reviewing in this unit. So we'll be going over this again, but again, it helps to understand how to work with factorials and how we can use cancellation here. So first thing I'm going to do is simplify in these parentheses right here. So I have 9 factorial over 3 factorial. 9 minus 3 would make 6 factorial. So I can rewrite that 9 factorial on top as 9 times 8 times 7 times 6 factorial over 3 times 2 times 1, that's a 3 factorial, times 6 factorial. And then again I have the cancellation. Keep simplifying. 9 times 8 times 7 over 3 times 2 times 1. Right, so 9 over 3 is 3 over 1. 8 over 2 is 4 over 1. So now I've simplified this down to just 3 times 4 times 7, which should just be 84. So trying this on the calculator, you can end up with some really big numbers. It can be difficult to put these things in. So working with them by hand, understanding the concept, is going to help you be able to work through these kind of problems faster. And we have sequences with factorials, or when we get into our binomial expansion again. So that's the next thing we'll be doing, is finding terms in a sequence that has factorials. So if we had a sequence that looked like this, an, our general term in the sequence, is 2 to the n over n minus 1 factorial. Let's say we want to find the first 4 terms. So just like in our video from day 1, first thing we'll do is start with our first term, n equals 1. So a1 would be 2 to the first over 1 minus 1 factorial. So that'd be 2 over 0 factorial. 0 factorial is 1. So this first term would just be 2. Second term, same thing, we're going to follow the formula. 2 to the second over 2 minus 1 factorial. That'd be 4 over 1 factorial. 4 over 1, just 4. On the third term, follow the same thing. 2 to the third over 3 minus 1 factorial be 8 over 2 factorial, just be 8 over 2, should be 4 again. And then the fourth term, 2 to the fourth over 4 minus 1 factorial be 16 over 3 factorial. 16 over 3 times 2 times 1. Right, so our 2 and 16 cancel out as 8 and 1. So I end up with 8 over 3. So do one more of these, and that's going to be it for this video. So another sequence using factorials. Say we have 20 over n plus 1 factorial. Right, and again, we want to find the first 4 terms. So we'll start with our first term, a1, plugging in 1. So that'd be 20 over 1 plus 1 factorial, 20 over 2 factorial. 2 factorial is just 2 times 1, or 2, so we get 10. Plugging in 2, we have 20 over 2 plus 1 factorial. That's 20 over 3 factorial. So again, we can write this out, so we can use some cancellation here. 20 over 2 is 10 over 1. So we can write this simplified as 10 over 3. For our third term, same idea, 20 over 3 plus 1 factorial. It's 20 over 4 factorial. So that'd be 20 over 4 times 3 times 2 times 1. And again, we can simplify here. 20 over 4 would cancel out as 5 over 1. So multiplying through, we'd have 5 over 6. And last one, the fourth term, 20 over 4 plus 1 factorial, 20 over 5 factorial, and we can work through the cancellation the same way. So 5 times 4 times 3 times 2 times 1. So 20 over 5 cancels out as 4 and 1, then 4 and 4 cancels out as 1 and 1. So we end up with just 1 over 6. So if you want to see some more examples with this, or find some other resources to help you understand working with factorials, you can just search for factorials and find some other resources out there for extra practice or better understanding.